Okay, so here we have another fluid statics problem, and this time we're dealing with manometers, and manometers basically give you a fairly accurate reading on small pressure differences. So this question gives us specific gravity of mercury, specific gravity of glycerin, and they say they want us to calculate the difference between points A and B, the pressure difference between points A and B. So over here I've redrawn the diagram in different colors just so you understand clearly what's going on. So we have water in blue, mercury in this purple color, and then green is the glycerin. So what we need to know for this problem is that pressure is of course a function of vertical depth, and so it varies linearly with vertical depth. So as we decrease in height, the pressure increases. And it's given by, pressure is given by this equation, P equals density times gravity times height. Okay, so we're going to break this problem down into different height points. So starting on the right side here with point B, we'll call this point 1, this height right here. Then we go down, we hit between glycerin and mercury, call this point 2. And then remember how we said the pressure will be the same at 2 points with identical depths? Well, that is exactly the case right here. So we can also say this is point 2. And then point 3 will be between the water and mercury. And then point 4 will be at A, which is the top height of the water in this sphere. Okay, so now to solve this, to find this pressure difference, what we want to do is use the basic equation. Definitely a good one to memorize. P absolute equals P gauge plus P atmospheric. And P absolute can also be written as P total. So here's the equation. But in this case, since we don't have anything open to the atmosphere, then P atmospheric is just 0. So now we can start to solve, and in this case we're actually going to have to do a system of equations in order to find this pressure difference. So the easiest way to go about this is to solve for P2. And so P2 will be P absolute. So P2 is going to be P gauge, which is effectively, so if we start from this right side, it's going to be PB plus the height rho GH. So PB, pressure at B, plus rho GH, which covers this height. So that equals, so that's P2 from the right side. Now we have to calculate P2 from the left side. And so similar equation, P2, again, P2 is absolute pressure. That's going to equal PA plus rho GH from 3 to 4 plus rho GH from 3 to 2. And that's going to equal P2. And then from there, we are able to do our system of linear equations and solve, and then we are able to get PA minus PB on one side, and you will get a long equation like this, and we're able to plug in and get an answer. And also we calculated specific gravity of mercury over here. We calculated the density of mercury and glycerin, and then we plugged those in there and there.